Let me continue the thing. Okay, here, so we have arrived there. So whatever the A term, U, zeta, we have something, isn't it? Plus U, zeta, neta, something, okay? Plus U, neta, something. This is what I told you to derive, okay? So this is something pi, which is equal to 0. This is our eighth equation, okay? So here, rather than writing this much, okay, I'm going to use another variable. For this one, I'm going to use a, small b, small c, okay? So here you can write a u zeta plus b u zeta neta plus c u neta plus pi it is equal to 0. I'm just using this to differentiate. We are doing different one, okay? Okay, now. So here you can write what is A, what is B, what is C. Okay, so from this, whatever the inside the bracket, you can write as a A terms, B terms, C terms. So I don't need to write, I guess. Okay, so see here, actually our equation capital A U X X plus B, okay, U X Y plus C U Y Y has this small pi, which is equal to 0, which has been transformed into zeta neta, where we are using different ABC. Even though this ABC also something different, isn't it? Small a, small b, small c is dependent on a, b, and c. Okay. So this is what we are calling as a canonical form. This is the canonical form of this equation. Okay. Yeah, so I'm just now we are only doing our this is we called as a common one. No? The common one, how it taking a canonical form. Okay, we are now going to find the canonical form of the hyperbolic. Hyperbolic equations, parabolic, elliptic separately also. Okay, so let's see how the equation has been changing. So that's what our purpose also here. Okay, so what is that? The question will come. So they will give you one, let's say, second order equation. Okay, whatever the equation. So first of all, you have to find out whether it is a hyperbolic or parabolic or elliptic type. Okay, so using the discriminant. Okay, then according to the type, it will the canonical form also will the process will be changed. Okay, after that we will derive something in terms of u zeta neta terms. Okay, so whatever u xx something terms, this kind of term will be changed into this kind of format. So that is our purpose of studying this here. Okay, so if you know why we are studying only, you can proceed. No, so that's what I'm telling. Okay, so let's proceed further. So I hope you understood the general second order equation. Okay, general second order equation number 1 has been transformed into a canonical form. Okay, we are not finding whether it is which type. We just find for the general idea of canonical transformations. Okay, where these equations is depend on xy term. This will be zeta xy again the neta xy. So you have think this is not we are transforming x to zeta, y to neta, but something a zeta which has independent again the independent variable x comma y, neta again x of y. Okay, so that's why we are using the chain rules. Okay, so those things hope you have understood. Okay, let me continue. Okay, so let's write something as a note. Okay, so yeah, write with me. The note is equation number 8. I don't know which number you have put. If you follow me, you can put 8 or you can put your number. Okay. Equation number 8 is not simpler than the original PDE. So hope you have know these abbreviations. Okay, this is equation. Or otherwise, you can write equation like this. Okay, so that's your choice. So PDE number, I think number 2, is that number 2 or 1? In my case, I put as 2. Okay, hope you have followed my same notes. So number 2, okay. So what they say is not only this again the canonical form, the equation number 8 also not a simpler form than the original form, but we're gonna check whether those are relatable by the idea of the Jacobian. Okay, so let's see. In case a b by 2, the small b, okay, small a small b by 2 c. So that's what it's coming as a b squared minus 4ac. Okay, so I told you this one already, I guess. Okay, so you also have zeta x zeta y and neta x neta y. Okay, and we're gonna find this capital A b by 2. So for that, we are gonna find the relations between the this Jacobian with this this discriminant and this discriminant. Okay, so b by 2 and c, and then again zeta x zeta y neta x neta y of transform. Can you see the? Okay, give me a second. I will write again. I don't know whether you can see my writing. I'll write again. Okay. So simpler than the original. Okay. So this one, zeta x zeta y neta x neta y times again our discriminant of our original one b by 2 c. Okay, zeta x zeta y again neta x neta y of transverse. Okay, so this has been derived from the equation number 8. Check whether, okay, not now, check whether this v squared minus 4ac can be written in this form. Okay, so what this says is, okay, tell me what is, we have studied about the, this is a 2 cross 2 matrix, no? In the 2 cross 2 matrix, what do you think, this one? Is that true? A and A transpose determinants are equal. So what do you mean by transpose? Transpose in the sense, we turn the row into columns, and it's like a rotation. Okay, for example, if I have 2, 1, 0, 3, let's say this is my A. So what about this transformation of this one? So I need to write this one here, this one here. Okay, what is the determinant of this one? Let's say 6 minus 0, isn't it? 6. What about the A transpose? Again 6 minus 0, isn't it? So you can check for any 2 cross 2 matrix, okay? So this is true. So they are saying if you take the determinant for in both sides, okay? I'll write in the next window, okay? Hope you have copied this one. So I will take the, so if you take the determinant both sides, let's say A b by 2, b by 2, c, which is equal to this one A b by 2, b by 2, and they say A is equal to A transpose, okay? So whatever sigma x, sigma y, neta x, zeta x, zeta y, neta x, neta y, again zeta x, zeta y, neta x, neta y, transform also there. So they say these two are equal, okay? So they are taking, I already told you the Jacobian, we are taking as a determinant of zeta x, zeta y, neta x, neta y, isn't it? So if it is both are equal, I can write Jacobian times Jacobian. So you can take as a Jacobian square. Okay, so these are some of the ideas. Okay. Also, what do you think? This one, AB. So is that possible? This one? I think this is your senior's vector space past paper questions. Okay, so to prove 2 plus 2 matrix, this one. Okay, so you can prove, or you can take any AB and see whether after multiplying AB's after taking determinant, which is equal to separately taking determinant of A and determinant of B's values are multiplied. Okay, check your answers. These are true. These are true. Okay, we are taking this one as a Jacobian. So Jacobian tangent. So I mean AB. I mean A into A transpose. We can write as A into A transpose. I can write as A into A transpose. What do you think this one is equal to? Any idea? A into N transpose is what? A into A transpose? Is that one? Are you sure? Not one. A into A inverse only one. I. Okay. So it's not I. Here we are not taking A into A inverse now. A into A transpose. Okay. So you have to be careful. So this is not I. So I'm just expecting this answer. Okay. Okay. So that's fine. So we are taking this as a Jacobian and transform also I mean, since this determinant are equal, so I'm taking this one Jacobian and Jacobian and times Jacobian. So I can write Jacobian square. Okay. From this, what you can conclude. So here you can write this is a Jacobian, which was we taken in our equation number 5, I guess. Okay. Okay. So let me continue. Okay. Please keep this in mind. Okay. So we're going to use that equations. So if you are having that equation, let's say A B by 2 B by 2 of C is equal to capital A capital B by 2 B by 2 C is equal to Jacobian square. So if you find the I mean this one, so you may have something like AC minus B squared by 4. So again, this one will be capital AC minus B squared by 4 times Jacobian square. Okay. So I can rearrange this. This will give you B squared minus 4AC. If you cross product 4 and writing the minus, taking this side and this side, it will be something we can get like a discriminant. Okay. Times D squared. Okay. So let's take this one as a delta. This one as this delta and Jacobian square. Okay. So what is this saying is, please write down. So discriminant of equation number 2. So what is the 2? 2 have the capital ABC. Okay. So discriminant of equation number 2 has the same sign. Same sign. I mean, if your delta less than, greater than, equal. So whatever we are taking for the original equation, that will be, since this is equal, okay. So we can also transform to our small discriminant also. Okay, I mean the canonical form discriminant. Okay, discriminant of equation number 2 has the same sign of discriminant of equation 8. Okay, transformed equation of transformed equation transformed equation number 8. Okay, so from this we have found okay, I will continue. Finish this one. So it means this delta's signs the same as the small delta. So whatever we are, if whatever the original type is the one from the canonical type also. Okay. So hope you have written this one. So I will continue. So it says from this we can conclude that it is clear that any real non-singular, so we are taking as a non-singular y, and that means Jacobian not equal to 0, transformations, okay, any real non-singular Jacobian, okay, transformation does not change the type, okay, type of PDE, okay. So what you have to understand is after we from the original one we transform into a canonical form, okay, so the type won't change in any way, okay. If it is the original way, we have found out b square minus 4ac, let's say I got equal to 0. So even if you transform it also, you will get the same. If it is b square 4ac, it is a parabolic, so same will come here also. Even if you check for the canonical form, it won't change the type, okay. It will change only the variable, okay. It's transforming for a purposes, okay. Since of why it is not changing, because it's on, we are only considering the coefficient, isn't it? So coefficients, in the sense it doesn't change anything. Coefficients only involves, okay. So that's why it doesn't change anything. Okay. Yeah, that's all about the general forms canonical idea. So now let's classify it according to the our types. Okay. And we can do some example, then we can finish it. Let me continue. Now, put the heading canonical form. Canonical form of the second order PDE. So I roughly okay, let's see the canonical forms. Okay, so I will roughly tell you what it will be. Yeah, we can. Okay, so that's a theorem. Okay, if zeta x comma y is a constant and neta x comma y also constant are characteristic of equation number 1. Okay. So we call zeta x comma y as a constant and eta as a characteristic equation of the our main second order equation. If and only if the zeta x comma y and eta x comma y are the solution of equation 8. Okay. So if you wanted to get a characteristic equation of 1 as theta and eta as a constant, we have to have, it is a if and only case. So both ways are, true. Sigma xy and theta and eta, both the solution of the equation number 8. Okay. Okay, what that it says is if theta and eta are the solution of equation 8, then we will have the theta is equal to constant, eta also constant are the corrected equation of 1. Okay. So continuously write down to choose zeta and eta. Okay. So in the case of the type of equations, okay, we have to choose the zeta and eta. We can't every time the general case only we have commonly taken, but for the types we have to choose it. Okay, as constant, so that okay. Yeah, so that equation number 8 takes, okay. So choosing some zeta and eta, our equation number 8 will be takes the simpler form of our types. Okay, simpler forms. So what are the forms it will take? Okay, so it will have three types of forms it will take. Okay, I will write in the next window. Okay, please write down these. Simpler forms. So let's see what are the forms. So in case of first one, in case of first one, let's say for hyperbolic, so we can prove this one, okay? Don't worry about it. If in the case of hyperbolic, what is the delta? Can you remind me? What is the sign of the delta? Is that greater than or less than or equal? I need everyone's answers. Yes. Others, please find the answer. What will be the delta, discriminant for the hyperbolic case? So when you're memorizing also, you have to be carefully memorize, okay? Don't confuse yourself to H hyperbolic comes, it will be, yes, good, greater than 0, isn't it? So if it is discriminant greater than 0, it means b squared. So we are considering our equation number 8. Okay, it depends on small a, b, c as a terms. Okay, so we have transformed our capital A, B, C as small a, b, c. Okay, so a, c, this will be greater than 0. So from this, what you can think? So in which case you will have the greater than equal to 0 case. So in generally, see here, we have b squared minus 4ac. So if you want this one greater than equal to 0, so what will be, depend on what? For example, b squared will be always 0, no? Are you agree with me? I mean, b squared, whatever the b squared, for example, if I put 0 squared, 0, 1 squared, 1, 2 squared, 2, 4. Even what minus 2 squared also 4. Okay. So see the answers, all the answers of squared will be always greater than 0. Okay. So in case of, let's forget about the 0. Always greater than 0, isn't it? So we don't need to bother about this case. Okay. B squared is doesn't affect anything because it's already greater than 0. So only thing is the sign depends on this one. So which case, so 4 is always greater than 0. So let's forget about the 4 also. So we also only depend on A comma C. Also negatives there, isn't it? Okay. So if you have negative, but you wanted to get it as 0, okay? So what do you think? In which situations it can be, these two are equal? I mean, we don't know A, B, okay? We don't know whether what number is this, but only possibilities I'm telling you is, no, yeah, one answer has here AC less than 0. That's okay, that's a thing. But if it is yes, A cross C is less than 0, that's fine. But we don't know about the A and C, no? So in generally, what do you think? In which situation which is equal? So I can't talk about B square. Okay, only thing is my 4 also I can't. AC. But if I choose A is equal to, see whether it is correct. A is equal to C is equal to 0. In this possibility only I can get this idea. Is that correct? So whatever B square always 0. Okay. B square something greater than 0 plus 0 will be always greater than 0, no? But otherwise it will be reduced in any point of A comma C. If it's taking negative values or positive values, even negative 1, even that case also it will be it will collapse this sign. Okay, they are saying if you wanted to have this one, B squared is fine, 4 is fine. Only thing is you have to take A is equal to C is equal to 0. Then only it will be true. Okay. Are you agree? Okay. Let's think about in that way. Okay. So I will erase these parts and I will write it again. Okay. So we will have only the solution. I mean, to get these hyperbolic cases, you have to have A is equal to, okay. Okay. So to get this point, you have to have the conditions A is equal to C is equal to 0. Okay. After that, so what will happen in the equation number 8, okay? If it is A is equal to C is equal to 0, we only have the B term, no? A term and the C term will be 0. Only we will have B times something. B times, I think B times U zeta neta, isn't it? So U zeta neta something pi is equal to 0. So I'm going to take this one in this side and I'm going to write B is greater than 0. So I can divide it by this one. So finally I will have zeta neta is equal to, let's say, some chi. Okay. Where this chi can be pi over B. Okay. Or negative pi over B or anything. Okay. Something. We don't bother this one. But it will depend on zeta, neta, u zeta, u neta, okay? So this term is nothing. So we are just taking different, variables, okay? Again, our meeting will end. Okay, so finally, we will have this equation as a canonical equation. We will prove this one, okay? So I'm going to prove this one, whether it is correct or wrong. Okay, I'm giving the theorem. We are not finishing the theorem, writing the theorem. We are just writing the theorem, okay? Okay, so what you have to write is actually just explaining the thing, but I'm not finished writing the theorem yet, okay? So give me a second. Okay, this is what you have to write. For hyperbolic case, okay, delta greater than 0, b square. So it is giving A is equal to 0, C. Therefore, our canonical form will be u theta neta is equal to 5. Okay, maybe this one theta neta u theta u neta. Okay, let's say this is my equation number A. Similarly, for parabolic, so let's finish up our theorem, then we can go. Okay, parabolic case, actually delta is equal to 0, isn't it? So in that case, we'll have b squared minus 4ac, which is equal to 0. So I will have something like, let's say, so which case you will have 0? So if you are having something this and this equal to 0, you should have this 0, this 0. Am I right? So you should have, so the condition is p is equal to 0, and so if it is 0, what is the idea of a and c? So minus 4ac is equal to 0. So 4 also I can divide it. So a will be, I mean, let's say, so if you wanted to get the 0, okay. Yeah, a is equal to 0. So I'm not talking about this c. Okay, first of all, I'm taking a is equal to 0. Or another case also I can take b is equal to 0, c is equal to 0. Okay, so we can have this in a different two ways. Okay, this also can be two ways, but I'm just considering this one. Okay, so in the books you may find like this also. B is equal to 0, C is equal to negative A, case for this one. See, if you, this one 0, where C is equal to minus A, you will have what? 0 minus 4, 8 times, sorry, yeah, A minus 8 times C. Okay, this will be again A. Give me a second. Yeah, this will be A, this will be minus A. This will be 4A square. No, this is also greater than 0. This is also a possible, but I am considering this one only. Okay, in this case also we have this possibility, but we are considering this one because we don't have that much of time to analyze all. Okay, for a time being, I'm just taking part of it. Okay, so you can write down if you have extra times, you can check that also. For elliptic case, as I said, delta less than 0. Okay, so you may have something b square minus 4ac less than 0. This is a complex situation. Okay, give me a second. Here, like, so our main equation will be changed like this now. Okay, equation number A. Similarly, my equation of parabolic will change into like this. U neta is equal to 5 something. Okay, this is our B. Similarly, elliptic case, you will have, for this case, you will have A is equal to B is equal to 0. Okay, so our final answer will be zeta plus U neta is equal to 5. Okay, this is the case for the elliptic. So this is our theorem. We are just in the declaring the theorem. Okay. The theorem says is zeta neta as a constant. Okay. As the characteristic equation of the equation of our main original equation. If and only if zeta and eta is the solution of the 8. Okay. And it will take the simpler form of this one. Okay. That's what the theorem. Okay. Let's try to prove these and we can follow some, we can solve some questions. Okay. So that's about our chapter 3. So I would like to finish somehow today. Let's see. Okay, I finished writing. So shall we prove? So write neatly. I'm just explained and write in this way. I just write carefully. And also analyze this one, whether it is correct, this one correct, this one correct. And in this case, we'll have A, B, 0. Mm, sorry, made a mistake here. So this is for this one, no? A is equal to B is equal to 0 for this case. Okay, so this case, elliptic case, we will have B is equal to 0, but C is equal to A. Then only we'll have negative A square. Okay, that is the less than 0. Okay, sorry about that. Just change this one. B is equal to 0. Now I have written this one again. B is equal to 0, C is equal to A, or A is equal to C, any time. Okay, so we should have anything negative. Okay. Okay, let's prove so you will understand more. Okay. Okay, let's begin the proof. First of all, let's take our zeta x comma y as constant. Okay, I'm gonna take C1. Okay, and yeah, neta x comma y also C2 or something. Okay, so we have to have C1 and C2 are constant. You can write. Okay, so we have C1, C2 are arbitrary constant. Okay. Then what is the total derivative is C. Okay, as I told you, the C is dependent on x comma y. So we have to use our chain rule to get the, yes. So this one also x comma y. Okay, so if you wanted to get the total derivative of x, zeta, first of all, you have to get zeta x of dx plus zeta y of dy, which is equal to 0. Okay, so this is our total derivative. Okay, from this, what you can take, can you find this one? What is dy over dx? So if you keep this term here, if you take this one this side, so negative there, so dy and dx down, so is that zeta x over zeta y? Is that correct? Correct, no? And also, can you find d neta like this way? Same. So what is dy over dx again in terms of neta? So this will be neta x dx plus neta y dy, which is equal to 0 since of the constant. Okay. And then this will be, I guess, neta x over neta y. Okay. So these are, we have two characteristic equations. Characteristic equations.